now, and I will not. There we go. Yeah, welcome everyone to the continuation of our monthly series. We weren't sure if we were going to be able to fit one in before the International Symposium, but we thought it was worthwhile, and we got a wonderful subject matter expert here. Oliver Hone is gonna walk us through his path towards MBSE and agility in the transportation, the ITS world. And sounds like it's going to be a fascinating thing. I'll just give you a bit of his background. For those of you that don't know him, Oliver is a very passionate SE practitioner. He's a technical fellow project manager, and he's a U.S. Global Technical Excellence Sector and practice lead on systems engineering, communications, and control for WSP USA, which is a large international and architectural and engineering firm, in case you don't know them. He's a recognized expert systems engineering professional and OMG certified modeling professional and certified Scrum Master and a PMP, running out of letters almost. Anyway, Oliver's got 25 years of extensive international and domestic experience. And he's been working in software and systems engineering across multiple industries. And he's really been working on leading systems engineering, systems thinking, integration testing in those different roles. So with that, I shall turn it over to Oliver and we can carry on.
Yeah, thank you. Let me share the screen over here. I guess you can see it.
Yeah, it looks good, Oliver.
Yeah, so let me just say hi once and then I'll sign off. Most of you, or many of you, may have seen me. I'm quite active at INCOSE. Anyway, so there, when you asked me, I said, yep, I think I have a good presentation I can present, and fully understanding that APTA, or our business, right, we are quite in rail a little bit, and also transportation is quite often in rail, not so much in automotive or in highways. The same, right, with a UK rail interest group. So I hope you'll like it anyways. So let me fast forward here, going to the next slide. Oh, dang it. That was the wrong button. Let me try this again. I was trying to get this, that big, let me go back here. I was trying to get that black bar disappearing from my screen, but I guess it wasn't working, so great. Let me try this one more time, share the screen. Here we go. So I'm not touching anything anymore. So just as a little introduction, I'm sure most, if not all of you, have seen this slide before. It's from 2008, and so the whole idea was that in the past, there's a lot of what was called document-centric. In the future, we would move to a model-centric approach, and so that specifications, interfaces, a system, trade-offs, test plans, everything would be in MBSE. And the whole idea is that you would go away from all those individual documents floating around. If you have ever worked on a larger project, there is literally hundreds, if not thousands, of documents flying around, and it's really difficult in different versions. Different people looking at them. So projects are quite, fragmented, so to speak. And the whole idea is to put everything into a shared system, right, the model, and then have different people looking at the same information. That's the whole idea. By the way, that project I'm talking about just last week received from the ITS New York an Outstanding ITS Project of the Year award. So it was quite something, I have to say. So I'm quite proud, right, having contributed. And in the middle, it's my client, Athena, and she was also very, let me put in the mouse also that I can point better. She was also very appreciative of all the systems engineering efforts we did. And I'm not sure you know, but the ITS world in the US is far more open to systems engineering than the rail industry. So that was really a really nice project. I think it might even have set the high bar in terms of what can be done. Having said that, the presentation I'm showing today is based on my presentation I gave at the 2023 MBSE Cyber Experience Symposium. Same title, right? And then let's just jump right into it. So from what I'm going to talk about is some background of what is an ITS project. Some people may not know. And then the actual project, which is a mouthful, Advanced Transportation and Congestion Management Technology Deployment Project, that has been coined later on the All Roads project. And then also the systems engineering and project delivery method we were utilizing. And then going to some of the challenges, what exactly has been done from a model-based systems engineering perspective, what were the outcomes, and then just the summary. So what is ITS? If you go to this website, right, there's an actual website for this whole thing, an intelligent transportation system, and it improves the safety, mobility, enhances American productivity throughout the integration of advanced communication technologies in the transportation infrastructure and vehicles. It has to do a lot with communications, with either with lines or wireless communication. And just to give you a couple of ideas, so several decades ago, it started out with having loop detectors, meaning you can determine how many cars are traveling, dynamic message signs, right, on roadways. I'm sure you all have seen this before. Ramp management, California, for example, is pretty adamant doing this. Traffic management center, like a rail control center. And then going forward, automated vehicles, and then even, right, I mean, this was already a big thing a couple of years ago, artificial intelligence, AI. And this whole thing is governed by the United States Department of Transportation. This is a website. As you can see, it's already over 30 years old, and they have a joint program office, and it's really sponsored, so to speak, by the US DOT. And you will, if you start digging in, my first encounter with ITS was easily 15 years ago, working on a different project. And there's quite a bit of they call it the regional ITS architectures, national ITS architectures. So there's a lot of stuff that is really very impressive. So let's talk about the project itself. Has 8 areas. It's in the Niagara region, so I happened to see the Niagara Falls a couple of times just because of that, which is pretty cool. But the actual project is in the Buffalo region. But it's the same, right? Buffalo's down here, Niagara Falls is further up. So the whole idea is, because it's close to the border, improve the border crossing performance between the US and Canada. Improve commercial vehicle operations. Specifically, right? You don't want trucks to come into the city and then they have idling engines, or they even have to stop, and because of they were driving for too long. Expanding regional smart mobility. I think the word smart shows up everywhere. Improve incident management, like if you have accidents or maintenance. Provide operational integration with NFTA, which is the regional public transportation. They have buses and rail. Then weather, obviously, right? If you ever have seen, like, was it 2 years ago in Buffalo where the house was frozen over? So they have a lake effect, especially when the winter begins, tons of wet moisture, right? Then turns into snow, and then you have easily up to 6 feet of snow. And then real-time information for travelers, and then last but not least, collect quite a bit of information, and then make it available to the people who want it or need it. This is, again, this presentation is from, as you can see over here already, the screenshots is from February last year. So very early when we started the project. So these are border travel times, right? You can see this over time of day between cars and trucks. You can see the message signs, you can see the lanes of how they're deployed, which ones are closed, which ones are open. Obviously cameras, you have public transportation, the routes and the vehicles, right? The buses, for example, are located. You have weather information with temperature sensors and the lights. From an engineering perspective, this is what I was referring to earlier. That's actually one of the most known books, I would say, in the US. It actually refers to systems engineering for intelligent transportation system, exactly what this is all about, ITS. It has some wings to the V model over here, right? Which goes for, you may be able to see it's a regional ITS or regional architectures. But the whole idea, it's a pretty good book, already 15 some years old, describing the systems engineering efforts quite well, which also can be used in our industry in rail. 10 years later, they developed a follow-up model, which was called applying Scrum Methods to ITS projects. And so the whole idea would be that you basically take the lower part, the implementation, the software development, and turn this into like an iterative, incremental, agile, you name it, process. Yeah. And the whole idea is to find more innovative ways to better manage the development and deployment of intelligent transportation systems, including connected vehicle projects. So if you take a look into more details into what this means, I'm not sure how much you're familiar with the US way of doing business, but there's what's so-called design build projects, meaning is the upper left V is what's called preliminary engineering. And then the detailed design or final design is going to be done by others, including the rest of it in terms of integration, testing, commissioning, you name it. And so literally the PE level would be done, or the conceptual level would be done using the traditional process, but the actual implementation would be used using an agile process. And so we would still follow the concept of operations, the system requirements, conceptual design. And this was our role. And I'm kind of happy to say that I only had one systems engineer, which was me, a project manager and a systems engineer. And we had some support with people writing the concept of operations. So I was responsible for the actual system requirements document. And then once the project started, there was a detailed design document by the design builder. And then the actual implementation process of the software was sprints or Scrum, right? And then the way it would work is you would break this up into several Vs if you want, or in sprints, and typically between 2 and 4 weeks long. Ours were 3 weeks long. And then what you do is you have what's called the product backlog, which is nothing more than all the requirements. And then you break this down and saying, which ones are we going to implement first, which are so-called sprint backlogs. And then you do your time, right, the 3 weeks. And at the end of those 3 weeks, you basically review what you have. And the whole idea is that whatever you have should be executable, meaning it's already good to go. And so what we and then right once you're done with the implementation, you would still go back to the V model. You would do factory acceptance test, integration test, system acceptance test. And unfortunately, it's all called typically construction oversight, even though the construction was more like software implementation. This presentation, as I told you, is from easily over a year old. So by the time we had, the idea was to have 16 sprints. It turned out to be 21 overall. Factory acceptance testing every 3 months. So the idea was Agile is a more, let's say, loose process, so to speak, right, in the eyes of many. And we really wanted to formalize every so often. And all the requirements that have basically have been implemented over the last couple of sprints would be formally tested, the full test plans and the likes. And then every 6 months, you would do an integration test, meaning testing all the interfaces to the external systems, and we had plenty. And then we also, had the idea of 2 themes, meaning is the whole we would be executed twice, right, with the system acceptance test. It turned out to be 1 only. But it worked really well, I have to say. I'm seeing a lot of, let's say, negative, feedback in terms of Agile, but I really believe most people just misinterpret Agile as let's just go ahead and no planning required, right? And that was not the case. In this project, not only did we have substantial planning at the beginning in terms of operational needs, system requirements, conceptual architecture. When the actual design builder came on, we had requirements workshops. If you're familiar with Scrum, you would develop user stories, acceptance criteria. So a lot of requirements management was done. Anyway, so what were the challenges we were facing? So complexity, document-centric approach, and then also the assessment of basically the oversight of a design builder, right? Completeness, correctness, and consistency. And so this is the software systems requirement document that I had authored initially on everything was done initially on paper. And so this is basically the all-road systems in here. And then on the left side, you would have the users, and then you would have quite a few. Those are the different user groups. These are the areas like border crossings. We looked earlier, truck parking, you name it. And then the external systems. And so the client has over 50 technologies in place. Not all of them were used eventually, only like a third, but still quite complex. Then there was a lot of standalone systems in the old days. And then with the new system, it's like a magnet and saying everything listens to me, right? The idea was to get all the data, crunch the data, and then distribute the data to the people who wanted to know or needed to know. Also, we had quite a number of requirements, almost 600. So quite a number of functional requirements of what the system is supposed to do, and then supporting performance requirements of how well that has to be done. interface requirements in general, how interfaces are to be structured, but also what kind of information is to be exchanged, and then overall system requirements in terms of, as you can see, with RAM and the likes. Yeah. So one of the challenges literally was the document-centric approach. So what you see here is the concept of operations. Those are the appendices having enumerated. I kind of like the idea that at the end of the day, after a long document, you have a list of here are the requirements. So we had the concept, the ConOps or concept of operations. We had a system requirements document. We had the conceptual design. Then when the design builder started, they developed the detailed design document. And then within the detailed design, they started creating use cases, sequence diagrams. And you can see already, if you ever worked in rail in the US, none of that you would ever get to see. Yeah, so it was quite impressive to see that the design builders in the ITS world are quite familiar with the whole systems engineering process, right? And then the actual sprint reviews, right? Every so often, as I said, 21 in total, and then all the different tests. And then on top of that, there was an Excel sheet managed by the design builder, which served as the requirements traceability matrix or RTM. And it would also include the user stories and acceptance criteria. So all of this is quite, actually, it's not that many documents, but I will show you in a couple of seconds, the challenges. So if you look into, or when we started looking to the detailed design document, this was a system context diagram, trying to, basically look and feel following what our contract document said. But then there was a system architecture right on the next page, which looked quite different. And then you had other diagrams, right, like this one and then that one, or close already to a UML look, but used, let's say, drawing tools, and then something totally different, right? So you could clearly see that this was not like a holistic approach. It was copied and pasted together. It turned out to be almost a 400-page document from different projects. And just to give you an idea, right, so this was a context diagram. So on the left side, you see 9 different user groups. One of them, right, it says Niagara Falls Bridge Commission. And then you go to the next one, to the system architecture, and all of a sudden it says NFBC, which is this one here, right, Niagara Falls Bridge Commission. But you have 4 users and say, wait a second, on the page before, yeah, you say 9 and here you say 4. Interesting. And then you go to the use case overview, right? So this is for border crossing, and then you see the NITEC supervisor, NITEC operator, NITEC administrator. And by the way, NITEC is that agency. It's an agency like a joint venture of 42 different agencies. They're just called NITEC. I barely remember, but it's something like a Niagara International Transportation Technology Coalition or so, something along those lines. And then every one of those use cases, right, would now follow into, in this case, sequence diagrams. But already now you had different users. It's like, wait a second, you didn't define this guy before, right? And then just on the next page, you had another name again, ICMS operator, which stands in the US for Integrated Corridor Management System. So you could see it was really even the intent to kind of make this all integrated, it was not. And then when we came to the actual sprints, right? So every time there was a sprint review, can you see it says the use case is view border wait times. And then it would have 1 requirement and 2 user stories, 1 and 2, and sprint number 2. Yeah, then sprint number 3 came along. And so for whatever reason, right, we had to retest some of this or some feedback and then say, hey, can we make this as a change? So next sprint comes along and it says view border wait times. And all of a sudden you have 2 requirements, which are different from the first one. Now we have 1 user story on. It's like, wait a second, yeah. But all of this was to be documented in the detailed design at the end of the day, detailed design document. And in this case, you have way more requirements. And so different requirements, no user stories, and different workflows. So now it's only 5 steps instead of 6. You can't see it, but it's 6, yeah. And this, I mean, if you really mean to be precise, and it's just frustrating, yeah. Anyway, so what did we do? So those are the challenges. So let's take a look into what we did from an MBSE perspective. And when we said it was really me being the only systems engineer. I had all the freedom in the world, which I, really chose to just use and do what I thought was right. So the whole idea, just taking a step back, is the MBSE efforts, just to be clear, were done from an oversight perspective. The design builder did not use MBSE. They used a document-centric approach and continued to use one. So what we did, or what I did, is I captured basically all the stakeholder needs from all the working groups, the system requirements for conceptual design as a basis for review, meaning as the whole idea for me was to saying, if I have to oversee, I need to know what the requirements are and where they come from. What I did is I created a framework in the model, and I will show you. I have the detailed step through, and then just over time started filling them into sprint 1, sprint 2, and then test 1, test 2. And then every time something came along, we could say, okay, so according to your sprint, you said these are the requirements over here. Those requirements trace to the use cases. Those use cases are part of your sprint. So let's see, right, what you did and whether this is in compliance. And this resulted in a very, very efficient and effective way of doing reviews. There was an investment at the beginning to set up the tool, right? And every time something came along, not only did I have to integrate our requirements, but also all the deliverables from a client, from a design builder. But again, I'll show you. And then also the whole idea was to show what is possible and that it works, and then hopefully using as a proof of concept, which actually has worked. So now we bought more licenses as part of our department. We're training more people. I got formally certified, and we use more and more projects, as literally as our day-to-day business as we do systems engineering. Just as a background, the timeline. So the actual project with the design builder started in March 2022. The system design, right, with the actual, the engineering part. So the difference here is really like the project management and the likes started about 2 years ago. I started the sprints, the actual implementation started in October 22. And I started literally at sprint number 3 by saying, I can't do this, right, all manually, right? This was all too frustrating. And then the project end from last year's perspective, was April 2024, and the project literally went live just last month or at the beginning of the month. So I think it really worked well, and the client, surprisingly, it's not only the client, WSP, even the design builder, very happy with how things worked. Anyway, so let's go and show some details. Yeah. So step number 1 was really putting the requirements, the system requirements, into the tool. Without doing, I'm not making any, advertisement here. Some people might recognize what it is, yeah. But literally, what I did is created already folders for preliminary engineering and final design. So that's the design builder down here, and then starting out with the actual requirements from the system requirements document. So can you see this document is broken down to functional requirements, performance requirements? So that's what it says over here. Then it's broken down, every one of those, right, the functions is broken down into border crossings, truck traveler parking. So this is what it says in here. And then, all the requirements are further broken down into the type of requirements like geographical scope, business requirements, stakeholder requirements, system context, you name it. And when I wrote the requirements document, I really felt a lot of people kind of grab one document only and never really care to read any other documents anymore. So I rubbed, the whole, even if it was a system requirements document, I wrapped all the stakeholder requirements, business requirements right into the user's face, so to speak, by saying, this is why we're doing this. Yeah. Anyway, having said that, and then last but not least, under border crossing, these are our requirements. When I wrote this document, I had to do this on the cheap, traceability. So first, every requirement became an identifier, leading with, in this case, BC for border crossing, and then system requirement, and then like in the old days, right, with basic like 10, 20. So if you ever have to sneak in some more requirements, and they were all traced by just, literally by putting in some parentheses and saying user needs so and so. So you could read the document and you could identify, requirements. And yes, it's a requirement because it has an ID. We didn't have any doers or whatever. It had to be done, as I said, on the cheap. And you can see where it's coming from. But anyway, so all of this went into the tool, right? The MBSE tool. And then you may see over here, so these are now the requirements, the system requirements. And as you can see, it says 10 and 40. And the whole idea was that 20 and 30, the requirements in here, were actually not due yet, right? Those was later sprints. So the whole idea was to build a framework, and then you start plugging into requirements on an as-needed basis because the tool also had to be populated. Having said that, so one of the first steps after I had the requirements in there by saying, gee, it would be really cool, right? All of those requirements, this is the actual Excel sheet from the design builder. that shows the requirements, but it also shows the user stories over here, the V&V method, and the acceptance criteria, and the sprint, right? When we know which sprint it was planned for. And so I said, this would be really cool if I had this in here. So what I did is I imported all of this. It's actually not that difficult as user stories. And then right in the next step, what you would do is you would link the user stories with the system requirements, right? So this is basically a matrix, requirements traceability matrix in the tool. And then on the left side, you have the requirements. And then voila, on the right side, all of a sudden, that was literally the first time I could see this in the tool, having the requirements and basically all the user stories in here, the acceptance criteria, V&V methods, and the sprints. And so one of the most powerful things is really to have everything in the loop, quote unquote. And so as I said earlier, right, so those were now, basically in a cheap way, identified by saying, oh, look, this is coming from a user need. So at this point in time, I still had to open the ConOps, find the ConOps, open the ConOps, find the page, and said, okay, this would be really cool, because quite often what happens is in the meetings, you're saying, you discuss a requirement, nobody remembers anymore. What is this all about? Where does it come from? And it would be really very beneficial to have it handy, so to speak, available at your fingertips. So the next step then was for me to pull out the ConOps, and then the ConOps was actually populated from stakeholder interviews. And so can you see it says interviews with stakeholders? So those were two different documents. And so from different, right, stakeholder groups. And the first one, can you see the first requirement in the ConOps over here, would actually come, you wouldn't see it in here, not even in the ConOps, but you would see it. It came from NITAG and NISDOT, which is the New York State DOT. So those two requirements were merged into one, which is not that obvious. I mean, it would really take a while, right? Then the second requirement in here came from the NFBC, remember the Niagara Falls Bridge Commission. And then the third requirement again came from the NITAG. Just to make it more difficult, like a shell game, right? All of those requirements coming from different areas, really difficult if you on the fly have to respond, where do those requirements come from? But now, can you see the first requirement is, oh, this comes from both NITAG and NISDOT, and then from NFBC, from NITAG again. And so now, well, this is what it looks, right? Imported, stakeholder interviews, it would say this is NITAG, the owner, this is requirement, already being traced to the ConOps, further being traced to the system requirements. So this is one viewpoint in model-based systems engineering from the stakeholder perspective, needs perspective. And then what you can do is you can filter. You can say, hey, show me everything, right? This is the Peace Bridge Authority. It's one of those 42, different bridge, different authority. And so you say, oh, those guys only have two requirements for border crossing, but one for truck traveler parking. So it's really powerful to be able to do this. And so having said all this, people would say, yeah, I get it, right? But isn't that what's requirements management all the time? Yes, up to here, you would probably still be able to say, yeah, fine, we can use doors or whatever. But doors does requirements only, and you will see in a couple of minutes or seconds. It's better if you have everything in the loop. Anyway, so and then right, if requirements were not listed over here, those are the ones not implemented yet, right? In terms of not as part of a sprint. So I literally populated this as on the go, as needed. So now I had a view not only from the system requirements, but I also had the view from the ConOps, right over here, the user need and the actual owner. And I also had the stakeholders, the user stories, the acceptance criteria, V&V method, all in one view. And then, so what I'm showing here is really what more or less what the design builder was supposed to do, but I showed it to them anyways, what you could do. By saying these are all the different system users. And then you say all of those are a type of, the system user, for example, the NFTA user, the NFBC user, right? And they're all part of or type of an all-road system user. And then when you read the actual requirements, they refer to an actual role, like a border crossing operator over here. So now you would say the border crossing operator is a type of NFBC user, it's a type of all-road system user. Then we also, showed them of, hey, you don't have, you remember your detailed design document is all over the place. You could do this in your architecture in a model, yeah. And so this was for showing this. And then also saying, hey, you remember all your use cases and all the sequence diagrams? Wouldn't it be great, right? You can do all of this. And this is what I mean is, this is where requirements tools fall short. I mean, there's just no way anymore to go any further than requirements. And so this is the use case, view border wait times, and then you can have activity diagrams, or you have sequence diagrams. So I explained, showed them some of them, how this could be done, right? And then you have a border crossing operator over here. You have the actual, let me show you, right? So these are the users, in red and blue, those are system components, and then those are external interfaces. I'm just for the sake of it showing this in different colors. And so those would be external data interfaces, and those would be internal interfaces. Those would be user interfaces. And then you would be able to show the data flow right between incoming data, outgoing data, and which brings us right to the next topic of interfaces. So now that you have identified the ATC-ATD system, and I guess I have to put my mouse again over here. What's the pointer options one? Bear with me, arrow options. Visible. Okay, very good. So what you can do now is you can identify interface blocks, right? And define, for example, for let's say the weather operation, right? You can say road conditions like current and forecasted and weather conditions, or you can even show whether they are incoming or outgoing. And this block would be applied to the actual system. So you now see an interface block over here. Actually it's a pod, and then you see incoming, outgoing data. And then if you want to go into some more details and even showing how this applies to the project, right? So this is basically now the information, for example, for the DTN, for the weather information. We just looked at this one over here, right? You can create nice tables. That's called the black box interface table. And I even used to show them by saying, hey, you don't have to go into crazy detail. You just give an overview of the interface. Then you point to the document section in here. And just to prove a point, right, this is the actual, can you see, it says here section 8.3 over here. So this was the actual section 8.3. And then there would be road conditions and current, right? So long story short, a lot of the stuff you don't have to necessarily put on a table in a complicated way and become inconsistent. You can actually do this in models, and then even use the models in documents. And anyway, yeah. So now that we moved on to the actual detailed design, so I was ready with my requirements, right? So what happened is we went into it's actually more implementation already, the sprints. And so the first sprint was quite frustrating because what we got to see was Jira tickets, which is like a management tool. There was only solutions. This is what the tool, this is what our system does. There were no traceability, no use cases. And I said, no, this is not how this works. Yeah. And I was really happy that I had support from my client. And so the sprint number 2, all of a sudden we had use case descriptions, right? The use case names, the requirements that will be addressed, a description of the users, the workflows. It really worked quite well, right? And then so now that those sprints were performed, every time after 3 weeks we had a review, I started taking this information and put this into the tool, right? You can see it's sprint number 1, sprint number 2, all the way down to 21 nowadays. So this one had 4 use cases, and I labeled them with sprint number 2, use case number 1, and then just the name over here. And from those sprint reviews, if you recall, they identified the user, the use case name, and whatever. I had even identified the requirements. So I was able in the tool to identify the use cases, the users, and for each use case, which requirement was satisfied, or actually refined in this case. And then you can build yourself nice tables. This is really the power of model-based systems engineering, of doing work once, and then you can look at this in 50 different angles, from 50 different angle versions or viewpoints. Can you see then, sprint number 3, number 4, number 5? So the number of sprints, the number of use cases vary quite a bit. So some of them are a little longer, different users like truck operators, and then, different bridge users. And then you have different requirements. And then before you know it, it gets quite complicated. Yeah. There's quite a number of requirements. You remember 600 we had, and then 21 sprints, and it's you can quickly lose control if you're not careful. And then also what I wanted to show over here is, can you see it says TI for traveler information, weather operation, border crossing, incident management. So the design builder was allowed to choose the order of whatever that you wanted to implement first, which also means it was all over the place. It's like a shell game in terms of requirements, not in a negative way, but very difficult to follow. And then at some point in time, where we imported also the detailed design document. So this is now the, it's a use case description and the detailed design. And so now I did the same thing, right? I took all the use case descriptions, put them into use case diagrams. Can you see it says NITEC user over here? So this one over here, it's for NITEC user. And so this is under detailed design over here. And then the same with requirements. Again, it becomes quite complicated over time. And then I started reviewing this against their own document. So this was the overview. We have seen this picture already before. And this is based on the design builder's own description of the use cases in the same document, the detailed design document. And then you say, wait a second, that looks different, right? And so it's different actors. Can you see? So you have 2 actors over here, you have way more over here. You have a missing use case. If you start counting only, it's 5 and not 6. And then inconsistent use case names. It's again the model-based systems engineering approach. Systems would really, the whole idea is to be consistent. And then what you can do is now that you from those sprints and the detailed design, as soon as you link the requirements, now you can again look at this from a different viewpoint. You can look at this from a requirements viewpoint. You say, okay, so this requirement has been addressed by all of these use cases. And then you can start taking a look and says, okay, so there were 3 use cases in sprint 3, right? And then 2, 3, 4. And all of them were supposed to be ending up in the detailed design document, but there's only 2 in here, right? They say, so something is missing. So you missed something already. Yeah. So this level of detail would be very, very difficult if you were trying to do this manually. Then again, right, missing actors or missing use cases, inconsistent actors, and then different requirements. And now we even started looking into the actual requirements, saying, are the use cases really refining those requirements? Here it says dynamic message sign, activate border dynamic message sign. Great, yeah. But this one also talks about dynamic message sign, but there's nothing to be seen with the use case over here. And then there's a detailed design, but no sprint use case. The same over here. And then here you have 1 sprint use case, but 2 for the detailed design. And here they're inconsistent, right? They're doing something totally different. But even worse, then some of them, right, over here have no detailed design use case or no use case whatsoever. So this was really, really powerful by saying you start plugging your requirements, you plug in all the use cases from all the sprints, and you will literally be able to measure the progress of have all of those requirements, have functional requirements, use cases signed. Then we did the same with testing, right? At the time, this is in factory acceptance test number 1 over here. So it came as a document. So what I did is I plugged this into the tool, right? Those are all test cases over here. All of those test cases have requirements assigned, which is really good. And then all of this have test steps. And then you can do the same thing, right? So now we can link all the requirements to all the test cases. And I don't want to jump out, but this is pretty big. I mean, this is a huge table. There's no way you can manage manually. I mean, maybe you can, but it will take you forever. And then also what you will be easily able to see, can you see it says view border crossing? It says 9 over here. So this test case has 9 requirements. We're saying, really, 9 requirements are quite different requirements, only 1 test case. And what you're expected to do is when you're supposed to read a factory acceptance test and saying it's complete, you're looking only at what's being offered, typically the test cases, but it's very difficult to tie them back to requirements, which is literally then again the other way around. So now I can say, now that I have the test cases tied to the requirements, I can read now the requirements and say, okay, this is a requirement. Again, the user story, remember, this is the acceptance criteria, which really came into handy sometimes if you said, wait a second, when are we done, right? What is acceptable? Then the test case has a purpose, the test steps in here, and then over here it would say, okay, it's compliant, yeah? Or it's not, right? Over here it says not compliant because I was reading the requirement, I was reading the test case, and I'm saying, no, it's not. And of the initial, I remember 112 requirements initially tested. The design builder said everything is peachy, and it said, well, not so fast, yeah, because once you're going through this in more detail, you find out that literally like 25 or more % were actually not compliant. And so 6 requirements had no test cases whatsoever, right? 3 were determined not compliant, the remaining 1 only partially compliant. Anyway, having said that, so what we were able to achieve with the whole thing, the 4 topics: traceability, viewpoints, communication, and also the review effectiveness and efficiency. So if I'm looking at the traceability, you remember, so I was able to use our requirements to tie in the user stories, the acceptance criteria, the user needs, and the actual owners of the requirements. I was able to see the requirements tied to the use cases. I was able to see the requirements traced to the test cases. Really, really powerful. The second one, viewpoints. You can look at the same thing from different angles. You remember this was a view from the stakeholder interviews. So this was literally saying, show me everything that you and that your concerns are, and how they trace to the ConOps, how they trace to the system requirements, and later on the use cases, the detailed design, the sprints, the tests. It's really, really, I don't know what else to say. Yeah, I would, if I could, I would do it over exactly the same way again in a heartbeat. Then from a requirements perspective, right, I can see the user stories, the acceptance criteria, the V&V methods, the sprints. So I could even, when I got a sprint planning, I could go in and say, okay, so you said these requirements would go into the sprint plan. Why do we say it's 10 and your plan says 15? Or the other way around. Then viewpoints, right? In this case, I could look at only some use cases, which is also really powerful because you typically want to see the big picture, but when you dive into the detail and you create too many drawings, you might actually become inconsistent. But with a model, everything is in a database, and you can just look at little things if you want, what's of concern, in this case, a certain sprint, right? And also, you remember when I said you can look into which requirements are verified by which test case. Really powerful. And then from a communications perspective, this is what we try to convey by saying, hey, you should really, your detailed design document you should make sure that you have all the users identified, that your architecture is identified, the interfaces, and how it all works. And all of those were in the detailed design document, but inconsistent, right? As I showed you with some examples before. So doing it this way will become very, very inconsistent. And then last but not least, from a review effectiveness, efficiency, from my perspective, it took some time every time, right, to invest, building a model, importing all the requirements. Every time I get a deliverable, like a sprint, review, test report, I had to always put it in, but it was worth it because at the end, I saved a lot of time and effort and found things I would have never been able to find with just manually searching. So, right, in this case, the inconsistencies between the detailed design, in this case, between the sprints and the detailed design, then between requirements coverage and the use cases, right, of the sprints, and eventually the actual testing of systems. Having said that, let me go a little summary over here. So what I have done with the presentation, right, I gave you an overview of what is an ITS system, what are the project focus areas of the initiatives, of the scope, so to speak, of a project. Then what kind of engineering process did we apply? Was it joined, literally like V model with Scrum for software engineering? What kind of challenges we ran into and why we did this in the first place? Then how we started building our first integrated, information in the loop, so to speak. Being able to add as we went along during implementation with the sprints, later on with a detailed design document. And I don't know what I did over here. So let me just, I was at the end anyways. Let's go here. And then also the test cases. And last but not least, from efficiency perspective or effectiveness perspective from the review. Am I sharing the screen? I guess not. Let me just.
No, it stopped sharing, Oliver.
Yeah. So I'm back, right? And so, yes. Long story short is that if I'm going back for 1 second here, so this is, I think, where the screen dropped, right? So by saying we were able to then up to here, right? This was really what we did internally, and up to, with this picture over here, this is when we started taking design builders artifacts, putting them into the model, including the detailed design, the sprints, and then also the tests at the end of the day. And it was really powerful from a review perspective. As I said, I would not have been able to do this manually by searching for all the information. And the conclusion is it has been proven to be very effective and efficient I will use it as a proof of concept, as I said earlier. This is already over a year old. And how many projects am I using this time? I would say at least 4 or 5 projects. Yeah. And that's it. That's what I have to say. Any questions?
Well, thank you very much, Oliver. Yeah, I think we have one in the chat, and then we'll open it up to the floor. Amike, if I'm pronouncing that name right, wants to know which tool you're using.
So we're not using a requirements management tool. I mean, the tool is Cameo Systems Modeler, and so using Cameo. So MBSE is 3 things, right? It's a methodology, it's a tool, and it's the language. And so the tool, it's Cameo. The methodology is literally model-based systems engineering, and there's different ways of OOSEM and then others. But I think I'm using this is one of the biggest challenges to kind of really what's the best way to organize your model. And then the language is SysML, and SysML includes requirements. So we are using SysML with Cameo as our requirements management tool. Because the whole idea is to have everything in the loop. So why would you even want to have your requirements outside, right? If you want to say these requirements are, refined by those use cases or satisfied by this type of system element or verified by this test case, you would not be able to link it if it was outside of the tool. So the whole idea is to have it all in the loop. To my point is I'm saying it's like, I don't need any requirements management tool anymore. I mean, I'm sure there is some areas where it's so specialized that it might have an advantage, but it's almost like a digital SLR, right? It's like in very, very rare cases it might still be better, but most of the time you can just use your phone. So that's the tool we are using for requirements management. Everything you have seen here was a Cameo Systems Modeler.
Thanks, Oliver. And again, thank you for that presentation. I'll kick off the questions, and then anybody else just go ahead and speak up. I had a question regarding our the industry that we both come from, which is transit and rail. Did you have any discussions when you were talking with DOT folks about the cross-pollination of what they've been involved in? Because I remember Federal Highways, they had the ITS SE handbook that they produced, which was like 400 or 500 pages many years ago. So they've obviously, like you said in the beginning of your presentation, they've been doing this for a while. Did you have any discussions with them about cross-pollination into other areas? Obviously not, FAA, because they already, are involved in this sort of thing, but more federal rail and federal FTA, Federal Transit Administrations.
So they'll know I have not, but I you remember 10 years ago I was presenting at VIS 14 how to get systems engineering off the ground, and one of the things is the Nike model, just do it. So I'm well beyond asking approval. I'm just asking forgiveness. I'm just doing it nowadays.
Yeah.
And if it works, right? And look at this, it even got like the outstanding project of the year. Or if it works, great, then make advertisement about it and saying this works great, let's do some more. And who's there to tell me that it's not going to work? Yeah. So one thing I have to be super careful. I want a word of caution is I'm using this for another project where I'm literally everything, you could call it like Visio-based systems engineering, yeah, or PowerPoint engineering. So all the graphics you have in documents, you can just replace them and don't tell anyone. And you have to draw them anyways. But the good thing is all the drawings you have in your documents become way more consistent because they're coming from the same model. All you do is you create a certain views and then just make it a picture. But for one thing, I would really caution is you can really very quickly confuse people if you show too much information or use information that is not understandable, where you almost need like a degree to read them, right?
Yeah.
So, but I mean, most things, I mean, people understand the block diagram, people understand the activity guide, the flow chart. So as long as it's just a line and you see that's a breakdown, or you see there's an arrowhead at the end of a line and this says A and B, then it's easy to follow.
Yeah, right on.
And
Thank
over
you.
time, you kind of normalize the whole process of model-based systems engineering.
Yeah, eventually it'll be in much more common use. Looks like Armin has his hand raised, so go ahead, Armin.
Hi, Oliver. Hi, everyone. Thank you, Oliver, for the presentation. That was a really good presentation. Thank you for sharing the knowledge and experiences. So I have two questions. First one is related to the previous question. So did you share the models and the content from MBSE with the client, or you were just sharing the document, the information from the model, like as a document sharing with the client? Because not everybody understands the MBSE outputs. And then sometimes it's tricky to just get them review and confirm the content of the model. Like, for example, very simple, if you say BDD, the first question is that what is BDD? What is the application? Not everybody knows
No,
what
I'm
is
with
the
you.
application. Yeah, and the second question is that in the slide, I saw that you have, like, from the requirements perspective, you had functional requirements and system requirements. I was just curious, what is the difference between these two based on the definition you have for these two buckets of requirements?
Yeah, so so let me answer the second one first. So that the template I already had received when I started the project. So it was already coined system requirements. Literally, functional performance are all system requirements. Yeah, but in that case, really it's you remember it was like RAM and stuff. So for the whole system without being a functional and non-functional requirement. I'm not sure that answers the question, but for the first one, for this very project, what I did is I said, I really, really want to apply MBSE on this project. I think it would be very beneficial. I had I think I was, fortunate in both that, it was the ITS world, which is more open to systems engineering, and B, that the client was very open, and my project manager as well. I said, look, in order to do my job more effectively or efficiently, I will be doing this, right, this approach. And as I said earlier, I'm not asking approval anymore. I'm saying, I want to be open with you. I'm sharing this with you. If you like it, I'll show it to you. But if you don't like it, then I'll just don't even bother anymore. But I also kind of applied, it's like, you please don't tell me how to do my job. Yeah. But they were very open. And so I basically did MBSE, so to speak, in the open. And one of the easy things is typically what I would do, the work products I shared with was an export. So for example, if you create a table, you just click on the button and voila, you have an Excel sheet. And so then I literally took the Excel sheet and then formatted it a little bit more that it looked nice, right? Sometimes even with some, I don't know, color coding in there so that people could follow. And then it just became an Excel sheet. It's literally an uncontrolled print, so to speak, from the model. But the true model, the true authority was still the model. But I did not share the model with the actual client, only either pictures or outputs. On other projects, where I'm doing the preliminary engineering, what we're doing is we are using a model behind the scenes and use only the viewpoints, the tables, the matrices, and put them into as figures or as tables in the actual RFP documents. And we're still not sharing the model, but we're saying, you, dear design builder, right, will have to carry it on forward from here. And then we have process requirement by saying, you shall use the same way you would say this with doors. You would say use or whatever, right, requirements. You would say, or for CAD, you would say, use this type of tool, and this is our manual of how to use it, 11/17, blah blah blah. Yeah. So the same way, I'm basically describing now what they will have to do through final design, construction, implementation, integration, testing, you name it, using a model-based approach. And then saying, I want to see your model every once in a month, right? Please submit me a model. Could we share our model? Sure, we could. But right now, we're not there yet. But if clients become more and more open, of course, we would say the same way. We would give them Word files that we use to prepare PDFs, or the same DGN files, right? For whatever drawing files we would create to use PDFs, again, drawings, you can do the same thing. So long story short is, right now, we're trying to get this more established, normalized, having the look and feel, consistency, and if clients are really interested, we're happy to share. Does that answer the question?
Yep. Thank you. That makes sense. Thank you.
So somebody, Was it Marcel, you with a note? Some other questions?
No, I think no, Marcel was just saying he's going to upload it to the YouTube channel. So yeah, any other folks? We got a couple minutes left for questions.
Yeah, maybe a little advertisement. So you saw this was the MBSE 23, right? The Cyber Symposium. I also presented just in May 24, and I also will present model-based systems integration at the IS 24 in Dublin. So there's more to come where this came from, is what I'm trying to say.
Yeah, no, yeah, thank you. Oh, Armin's got his hand back up. Go ahead, Armin.
Yep, sorry, because nobody has question. I'm going to go for another quick question. So for the MBSE side of it, did you use a specific methodology, like MBSE methodology for implementing the model?
I would like to say yes, but it's really I'm really following actually the industry standard. You remember when I said I broke this up into the PE level and then the final design, and so the easiest way for me is to literally make it recognizable. But you would see if you take a look again at the slides, it would say something under PE like stakeholder interviews. It would say concept of operations, system requirements, conceptual design. Under PE, it would say something like detailed design, sprints, testing. So there are actually like at least 3 different methodologies described. One is the object-oriented systems engineering method. Then there's, I think, from IBM, there's one. There is one. Man, I'm drawing.
Magic
I even
Grid,
have a book.
maybe Magic Grid, IBM Harmony, maybe because you used doors. I was like curious to see if you used any of those methodologies
No,
specifically.
I
Okay,
did not. Yeah, and
great.
the one I actually like is you may see the Magic Grid approach from it's the Salt Systems, who's the owner of Cameo. They have like a matrix where you would say basically the life cycle. You would start out with the user needs and then you would go to system requirements and then conceptual design and detailed design, and then you have columns for requirements. You would have columns for structure. It's a nice way of doing this. Yeah. Long story short is there's different ways of doing this. I don't think I really followed exactly one of them. I followed what I thought was right in my project, but it really worked out quite well. Maybe I should coin one or create one. Yeah.
Great, thank you.
Mm-hmm.
Great. Any other questions from anybody? Just I can pop one in just real quick. What would you estimate, sort of your learning curve was just time-wise, Oliver, for both the modeling language and then maybe, somewhat less importantly, the tool, but it's all kind of part of a package, I guess, as far as, the amount of time it takes you to learn and become actively productive, I guess, in the tool. What would you estimate that took?
Well, I can give you exact numbers for this one. It really comes down to how motivated you are and how much, let's say, pre-knowledge you already have. So this presentation was from May 23, and I had started for this project applying this in earnest. I remember it was December 22, so half a year for everything, building the model and preparing the presentation. But then I would not. I mean, you shouldn't not be fooled. Yeah, if you're familiar with requirements management and tracing and doors, that's one type of link. It's a trace. Yeah, in SysML, all of a sudden you have tracing, but all of a sudden you have derived requirements, refined requirements. You have satisfy, you have verify, and it can really become very quickly very complex. So I would say to really get your feedback and start using it. Ideally on a real project to have a real task at hand, not just to tinker around, probably half a year to a year, I would say.
Okay.
And then you just as you go along, yeah, you will learn a lot over time. I mean, I feel like I'm just scratching the surface. Yeah, there's so many things you can learn, and this is even only SysML and one tool. I mean, I'm not sure you remember, but even at the IS 14, I had already MBSE diagrams shown. I had used Rhapsody back then. I used Spark's the enterprise system with like system enterprise architect back then. But still, it's you need like a mission to actually apply it. Otherwise, it can become overwhelming.
Yeah, no, it makes
And you
sense.
should obviously know systems engineering. I mean, really, this is like another step, right? You can't really just go from 0 to MBSE. I mean, if you have software engineering, fine, yeah, but you really need to understand the whole idea of requirements, users, architecture, structure, behavior, right? You need to have like some understanding of it.
Right. Yeah, you need that intuitive aspect of, where you've actually lived and worked a large part of the system life cycle and experienced it. And yeah, excellent. All right. Well, just to wrap up, I just want to thank, Jonas, do you have a last quick question? We're at our time, but
I do. So real quick. So, what the concept of a single source of truth, how do you recommend, or if you were to start from scratch or whatever, on a big project, you have the owner, you have the designer, you have the design builder or the contractor. How do you manage who ideally should own the model and manage the model and have access to the model, etc.? Have you any thoughts on that? I'm talking like
Yeah,
in
I
a
mean,
perfect world.
Yeah, and so not everyone might know, but Jonas and I work now together on the Penn Station reconstruction project I just joined. Yeah. And I'm also again, basically just proposed how to use MBSE. But long story short is the PE designer, WSP, right, serving as a PE designer would go away at some point in time. So and then a new final designer would come in, and so the owner really is the one who should really manage. But quite often the owner not and I'm not talking about the actual consultant for the owner, but the owner, they are not very familiar, so they typically delegate. So in reality, you leave it to the engineering team during PE, and then you hand it back to the owner, and the owner would then give it to the final designer. That's what typically reality would be. I mean, just imagine the same thing with all the contract documents, whether it's a scope of work or requirements. You prepare something on the PE level, give it to the owner. The owner, we use it as part of the RFP package, gives it back to the next level contractor. So, but it should really be, ideally, it should be the owner, so to speak. Yeah.
okay.
So yeah, thanks for that.
Oh.
Mm-hmm.
Yeah.
Thanks, Jonas. We have one more. We can take one more quick one from Niran. He's asking what your current and future interoperability is. Did you want to explain that a bit more, Niran?
Yes, can you hear me?
Yes.
Yes, yes. I was thinking, what is your opinion in terms of interoperability? Because you've used, I think you said you used Cameo, and you've used Spark before. Now you've used other kind of vendor provider. What was your opinion of interoperability? Say, for example, if I design my MBSE kind of model in Cameo, how can I use it on can I use that same model on another platform? And so what's your opinion about it?
You can, but every supplier, like in the real world, right, tries to put some extras on it so that he can't anymore. And by the way, you can convert the model, but not the views. You would have to create all the views and the tables and the likes. So there is some, but you probably, benefit from choosing wisely the tool and then use it for a while. Yeah.
Just the last one. Would you make any recommendation for which one do you think is still the best for now?
Well, it's having worked with all three.
I'm sorry for asking that kind of question.
No, having worked with all three, I really feel the one I have been using, I'm purposely not using a name now, yeah, is the most intuitive. And also, if you go to training, if you go to conferences, you can see that Cameo, I mean, just saying the name, yeah, is most prevalent nowadays. And I'm sure it's for a reason.
And I can maybe add on to that the INCOSE tool lab, I think it might be under some construction right now. It was up and running. I'm sure it'll be up and running again soon.
Yes, it's available. Yes.
Oh, is it? Great.
Yes.
Great. Thank you.
Fantastic. Thank you very much.
Yeah, so that'd be a great place to explore the different options, because we're, at INCOSE, we're trying to be careful not to be, seen as favoring a supplier over another supplier. So, yeah, that's a great way to do that. I'm gonna have to end
Thanks a
this
lot.
now, unfortunately. I appreciate everybody's patience with all the invitation stuff. I'm gonna stop the recording now, which I just did.